Hello students, so welcome to AIMS India's online classes. Today, from mathematics subject, polynomials topic we are going to discuss. So our today's concept is relationship between zeros and coefficients of a polynomial. Relationship between zeros and coefficients of a polynomial. It may be linear, quadratic or cubic. One by one we will be going to learn. So if you have a linear polynomial like ax plus b, its 0 will be minus b by a, which we have learnt already. We will now try to explore the relationship between zeros and coefficients of quadratic polynomial. Means the polynomial whose highest degree is 2 or which is in the form of ax square plus bx plus c equal to 0. For these kind of quadratic polynomials, we are going to learn relationship between zeros and coefficients. Means zeros means, so values of x are called zeros, and here ABC, the constants are called coefficients. Or C actually it's constant, A is x square coefficient, B is x coefficient. Suppose, let us take one quadratic polynomial, p of x equal to 2x square minus 8x plus 6. So how to factorize this? So 2 into 6, 12. This middle term minus 8x to be divided into two terms such that sum is equal to middle term, product is equal to product of A and C. So minus 6 minus 2 minus 8x. So minus 8x is split as minus 6x minus 2x, and minus into minus plus 6 to the 12. X into x, 12x square. Here 6 into 2x square, 12x square. Same. So 6 into 2x square, 12x square. So the middle term minus 8x is split as minus 6x and minus 2x, which is whose product is equal to 12x square. From first two terms, let's make first two terms one group, next two terms another group. In first group, let's take 2x common, x will be remaining, minus 3 will be remaining. Let's take minus common, 2 common, x will be remaining. Because of minus common, symbol will change, minus 3 will be remaining. Again, x minus 3 is common from both. X minus 3 we can take common, 2x is remaining here, minus 2 is remaining here, 2x minus 2. From this 2 we can take common, 2 into x minus 1, x minus 3. This is the factorization, or these are the factors of the given quadratic polynomial. So now, means these are the factors. Means what does it mean? So p of x equal to 2x square minus 8x plus 6 is 0 when x minus 1 equals to 0 or x minus 3 equals to 0. Because this is the quadratic polynomial, the value of quadratic polynomial will be 0 if the one of the factors is 0. Because 2 is constant, it can never be 0. X minus 1 can be 0, x minus 3 can be 0. So then only this quadratic polynomial will be 0. So this will be 0 when x minus 1 equal to 0 or x minus 3 equal to 0. Means when x equal to 1 or x equal to 3. So these two are the zeros of given quadratic polynomial. 1 and 3 are the zeros. Now let's see if these zeros have any relationship with the coefficients of terms in the polynomial. The coefficient of x square is 2, the coefficient of x is minus 8, and the constant is plus 6, which is a coefficient of x power 0. Coefficient of x power 0. Okay. So sum of all zeros means 1 plus 3. How much? 4. So directly if we do the sum of zeros, we are getting 4. But with the help of coefficients, is there any possibility of getting 4? Is there any possibility of getting 4? We can write it as minus 8 is there. Minus of minus 8 by 2. 4 can be written as minus of minus 8 by 2. So minus of, what is minus 8? Coefficient of x. What is 2? Coefficient of x square. So if coefficient of x is, if it is in the form of ax square plus bx plus c, then coefficient of x will be b and coefficient of x square will be a. Means the sum of zeros is in the form of minus b by a. Minus b by a. What is the product of zeros? 1 into 3. 1 into 3, 3. Which can be written with the help of coefficients 6 by 2. We can write it as 6 by 2. 3 can be written as 6 by 2. Where 6 is a constant term, 2 is coefficient of x square. Constant term means c. Coefficient of x square means a. So product of roots, product of zeros can be written as c by a. So like this we can relate zeros and the coefficients. If the roots are alpha and beta, then alpha plus beta equal to minus b by a. Then alpha beta equal to c by a. In this way, for quadratic polynomial, we can establish one relationship between the zeros and the coefficients of x terms. Next. Let's take some more quadratic polynomials. P of x equal to 3x square plus 5x minus 2. So here 3x square into minus 2. 3x square into minus 2, which is equal to minus 6x square. So middle term plus 5x to be divided into two terms, whose product is equal to minus 6x square. So we can write it as 6x minus x, so that plus into minus minus 6x into x square, it is equal to minus 6x square. First two terms one group, next two terms one group. In first group 3x is common, x plus 2. In second group minus 1 is common, x plus 2. Again x plus 2 common, 3x minus 1. So the quadratic polynomial will be 0. Either first factor is 0 or second factor is 0. Means either x equal to 1 by 3 from this, x equal to minus 2 from this. So 1 by 3 and minus 2 are the zeros of given quadratic polynomial. So sum of zeros, 1 by 3 plus of minus 2, minus 5 by 3, minus 5 by 3. Here 5 is coefficient of x, 3 is coefficient of x square. So minus coefficient of x by coefficient of x square means minus b by a. What is product of zeros? 1 by 3 into minus 2, minus 2 by 3. What is minus 2? Constant. What is 3? Coefficient of x square. So c by a. Like this, we can establish two relationships between sum of zeros, between product of zeros and coefficients. Okay, children, in the same model, try to find out zeros of the given quadratic polynomials, find their sum and product, and verify the relationship with coefficient of terms in the polynomial. So we have done two examples, children. Based on the two examples, these 4 questions you can do them as a homework. Next, children. In general, if alpha, beta are the zeros of quadratic polynomial, p of x equal to ax square plus bx plus c, where x square coefficient a is not equal to 0, So then normally x minus alpha and x minus beta will be the factors of p of x. Means the given quadratic polynomial ax square plus bx plus c can be written as a product of x minus alpha, x minus beta, means product of factors, along with that one constant k, where k is a constant. So k we will keep it outside. X into x square minus alpha plus beta x plus alpha beta, or k into x square kx square, k into alpha plus beta x, k alpha beta. So if this is the quadratic polynomial, then we can write it in terms of zeros in this form. So comparing the coefficient of x square, x and constant term on both sides, a value will be k, b value will be minus k alpha plus beta, c value will be k alpha beta. Then alpha plus beta equal to minus k alpha plus beta by k. So minus b by a. Alpha beta equals to c by a. Like this relations we will get. So this is the proof for relationship between zeros of the polynomial and coefficients of all terms of the polynomial. So alpha, beta are the Greek letters, children. So pronounced as alpha, beta respectively. So sometimes we make use of one more Greek letter, gamma, which we are not using here. But for some kinds of polynomials, we make use of this Greek letter also, which is pronounced as gamma. So sum of zeros of quadratic polynomial alpha plus beta, the formula is minus b by a, minus coefficient of x by coefficient of x square. Product of zeros equals to alpha beta equals to c by a, constant term by coefficient of x square. Okay. Next example. Find the zeros of quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and coefficients. So the product of a value 1 into c value 10. So a value 1x square, c value 10, 10x square. Middle term 7x to be divided into two terms whose product is equal to 10x square. So 7x we can write it as 2x 5x. So that sum is 7x, product is 10x square. If we take, or simply we can write 2 5 times 10, 2 5 times 10, 2 5 times 10. So we can write it as a product of x plus 2, x plus 5 directly. Or you can solve, you can take common, you can expand like this, you can take the common, you can take the terms common, you can group them and you can write the factors. Or if you are having grip over that, so directly as 2 5 is 10, x plus 2, x plus 5. Like that directly also we can write. So this will be 0. The given quadratic polynomial will be 0 when x plus 2 equals to 0 or x plus 5 equals to 0, or when x equal to minus 2, x equal to minus 5. Therefore, zeros are minus 2, minus 5. What is sum of zeros? Minus 2 plus of minus 5, minus 7. So coefficient means minus 7 by 1. Coefficient of x by coefficient of x square. What is product? Minus 2 into minus 5 plus 10 means 10 by 1. Constant term by coefficient of x square. Example 4, children. We have x square minus 3. X term is missing here. X square plus 0x minus 3. X term is missing here. For these kind of questions, how to find the relationship? So this is in the form of x square minus root 3 whole square, which is in the form of a square minus b square, whose expansion is a plus b into a minus b. X square minus 3 can be written as x plus root 3 into x minus root 3 into x plus root 3. This quadratic polynomial will be 0 when this factor is 0 or this factor is 0. Means x equal to root 3, x equal to minus root 3. Therefore, zeros are root 3 and minus root 3. What is sum of zeros? Root 3 plus of minus root 3, 0. Means coefficient of x minus of coefficient of x by coefficient of x square. Here there is no x, so x coefficient will be 0. Coefficient of x square 1. 0 by 1 is 0. Hence the relationship proved. Product of zeros. Root 3 into minus root 3. Root 3 into root 3 minus 3. Minus 3 by 1. So what is constant term? Minus 3. What is coefficient of x square? 1. So the relationship proved. Next one. So find the quadratic polynomial, the sum and the product of whose zeros are minus 3 and 2. We have to find a quadratic polynomial whose sum of zeros is minus 3, whose product of zeros alpha beta equals to 2. Let the required quadratic polynomial be ax square plus bx plus c, whose zeros are alpha and beta. Then alpha plus beta equal to minus 3, which is equal to minus b by a. Alpha beta equals to 2, which is equal to c by a. Which is equal to c by a. Which is equal to c by a. So directly, if we guess the values, this it can be written as minus 3 by 1. 2 can be written as 2 by 1. Minus 3 can be written as minus 3 by 1. 2 can be written as 2 by 1. But minus of b by a. So minus of plus 3 by 1. Here just 2 by 1. If we write like this, if we guess, a value is common in both. A value is 1. B value is 3. B value is plus 3. C value is 2. Like that, just we can guess. So one quadratic polynomial is a value is 1, 1x square. B value is 3, 3x. C value is 2, 2. X square plus 3x plus 2. Just by guessing, directly we can write the quadratic polynomial. Suppose, if a is not 1, if a is any real number, let's take it as k. So then, b minus a, in the place of b minus b by a, we can keep minus b by k equal to minus 3. C by k equals to 2. C by k equals to 2. Means minus b equal to minus 3k or b equal to 3k, c equal to 2k we will get. And a we have taken as k. So what will be the equation then? Kx square, 3kx, 2k. Like that also we can write the equation. We can write the quadratic polynomial. Next one. Find a quadratic polynomial if the zeros of it are 2 and minus 1 by 3 respectively. They have given zeros, not product, not sum. Directly they have given zeros. Alpha equals to 2, beta equals to minus 1 by 3. Like that, directly they have given the zeros. Let the polynomial be ax square plus bx plus c, where a is not equal to 0. This condition is compulsory, children, because if a is equal to 0, then there will be no x square term. It won't be considered as a quadratic polynomial. So, and its zeros be alpha and beta. So then alpha equals to 2, beta equals to minus 3. Sum of zeros 5 by 3. Product of zeros minus 2 by 3. Therefore, What is a quadratic polynomial? Already in concept we have learnt k into x square minus alpha plus beta x plus alpha beta. K into x square minus sum of roots 5 by 3 x, product of roots minus 2 by 3. So because here 3 is there, for in the place of k we can take any constant. Because here 3 is there, for cancellation of 3 we can keep 3 value here. So then it will, in the place of k we can keep 3. Then it will become 3 into x square minus 5 by 3 into x minus 2 by 3. With 3 we multiply all terms, 3 into x square minus 3 into 5 by 3 x, so minus 3 into 2 by 3. When we multiply like this, 3 into x square, 3x square, 3 cancel, minus 5x, 3 cancel, minus 2. This will be the quadratic polynomial which is having roots 2 and minus 1 by 3. So according to our requirement, we can take the value of 3. Next children, you have to try these questions. So quadratic polynomial whose zeros are minus 2 and 1 by 3. You have to find quadratic polynomial which is having these roots. And you have to find quadratic polynomial whose sum of zeros is minus 3 by 2, product of zeros is minus 1. Means example 6 model, example 5 model. 2 questions are there. So try to solve that questions, children. Try to solve that questions. So okay children, that's all for today children. So please visit our website children, www.aimstoday.in, for other information regarding online classes, quizzes, live worksheets, do it yourself activities, English classes, coding classes and other things. So thank you for watching our video children. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you children. Have a good day.